So in this video here, we're going to be talking about special right triangles, specifically the 30, 60, 90 triangle and the 45, 45, 90 triangle. So when you have these degrees already made, then the sides or the lengths of the triangle are proportioned in a certain way. So like with 30, 60, so this side's already 90 degrees. This side here would be, since this side looks smaller, I'm going to make this 30 and this side 60. So it turns out whenever you have a 30-60 triangle, the short side, this here's the short side holds the bigger angle, or the bigger angle compared to these two. So the angle that's 60. The short side holds the 60 degrees. And for these types of triangle, the short and the long sides are kind of associated to each other. So if this is a length, then that means that the long side is twice the length, or 2 times the x length, okay? Whereas the side that is the other leg, so this is one leg, the short leg, this here is the other longer leg, is in proportion as well. It would be x times the square root of 3 to get that length. So just remember 2 key things about 30, 60, 90 triangles, and it's the short side always holds the 60-degree angle, and then the hypotenuse is always twice the amount or twice the length of the short side. And that's how I remember a 30, 60, 90 triangle. For 45, 45, 90 triangles, they're a little bit easier to remember because both of the angles are the same. We also call this an isosceles triangle because if this angle is 45 and the other angle is 45 degrees, that means both of these sides have to be equivalent. So these sides are the same, and then the hypotenuse is the length x square root of 2. Essentially, take your length, whatever length you're given, and multiply it by the square root of 2. And you have your 45, 45, 90 triangle. All right, let's use some examples here to help us practice some of these skills. So when I'm looking at a problem like example 3 here, it's asking me to find the exact values of the indicated variable. So I'm looking for y and r in this case. And what I know is that this first triangle is a 30, 60 triangle. Even though I'm not given an angle here, this is already 90 degrees. That means that these two have to add up to be 90 degrees, or they're complementary of each other. So in this case, 90 minus 30 makes this 60 degrees. So that's how I knew very quickly it's a 30, 60 degrees. So when I look at this here, I notice that the long leg here, right? Or in this case, this angle is 30. So this piece is equivalent to this guy here, x square root of 3. So I'm just going to write that down because that could be an equation that I could work with. And what I don't know is this guy's length and this guy's length. But I do know that y should be x, the value of x, right? Whatever this x is, this would be the value. And this r here is going to be twice whatever x's value is. So I can start brainstorming here. Now, if I want to solve for x, I could just try to move things around until x is by itself. And that's what I'm going to do. So if I divide, say I divide square root of 3 to both sides, that cancels. X drops down. I have a 15 over square root of 3, but that won't do because a root is in the denominator. So I'm going to multiply the top and bottom by a square root of 3. So this would give me x, actually let me write it this way so I have more room. X is equal to 15 square root of 3. And then in the denominator, this is a square root times another square root. Since they're both square roots of 3, the roots cancel, bringing out just a 3. And if I reduce 15 and 3, that is 5. So this is really 5 square root of 3. Okay, so that x right there is equivalent to square root, so 5 square root of 3. So that tells me that this x right here is that value, so y is equal to me write that up here. Y is equal to 5 square root of 3. So I found what y is. Now let's find r. So r is equal to 2x. I already know what x is. It is 5 square root of 3. So if I work this out, this is going to be 10 square root of 3 because 2 times 5 is 10, and then bring down the square root. And that's it. So I found my y, I found my r here, so I found the two variables that were missing. And I'm going to do the exact same thing with part B. So in part B, I notice immediately that there's a 45-degree angle. So that means that this side here also has to be 45 degrees because these sides are complementary of each other. They both add up to be 90 degrees since this side's already 90 degrees. If that's the case, they're both 45. This is an isosceles triangle. Both sides are equivalent. Since I already know that this side is 2 square root of 5, this x here has to also be 2 square root of 5. So I've already figured out that x here is equal to 2 square root of 5. To figure out what is r, well, r, if you look at the theorem here, is x square root of 2. Well, x here, this side, was 2 square root of 5, so all I have to do is plug in 2 square root of 5 and multiply that by the square root of 2 that's next to it. So this x was 2 square root of 5, and this 2 is next to it. And if you work this out, you'll just multiply the numbers in the roots together. So 5 times 2 is 10. So this is going to be 2 square root of 10. This 2 just came out or came along, and then these roots multiply to give you square root of 10. So in this case here, my r is equal to square root of 10 as my final answer. All right, and for the next problem here in example 4, we're going to be finding the angle in degrees and radians without a calculator. And they give us a hint. They say, first, determine if the triangle is 30, 45, 30, 60, 90, or 45, 45, 90. And I think this is just helping us, narrow down what type of triangle it is so we can easily find the angle if we can't use our calculators here. So this one here is sine. So the first thing I'm going to do is build a triangle. So if I were to build a triangle, maybe I'll place theta here, make this a right triangle. And this here is sine. So sine SOHCAHTOA is going to be opposite over hypotenuse. So this is opposite, which is the square root of 3. And then hypotenuse is right here, which in this case is a 2. So I need to figure out what angle sits here maybe. But before I do that, let's just understand what type of triangle this could be. So I don't know if this is a 45 degree triangle because I don't know if this side is the square root of 3. If both of these legs end up being the same size, then I can say it's 45. But I don't know that. So the best thing to do is probably figure out what this length is before I can make that determination. So to figure out what this missing length is, I'll just use the Pythagorean theorem. So if I move this up just a little bit. So if I take x squared, my two legs, x squared, and add it with the square root of 3 squared. So I took this guy, squared it, took this guy, square it. Now I'm going to add them together, and it should give me the hypotenuse squared. So 2 squared. So x squared drops down. If you square root, they cancel. So this is just left with 3, right? Because the square root and the square cancel. And then this drops down a 4 because 2 squared is 4. If I subtract the 3 over, I get 1. The square root of 1 is 1. So that means that my x here is equal to 1. And when I look at this here, what I notice is that this side here, this is a 1, and this side is double that amount. So anytime the short side, and this is definitely, 1 is shorter than square root of 3. If you take square root of 3 and put it in a calculator, actually, let me do that right now. I'm going to take square root of 3, put it in a calculator, In decimal forms, this is about 1.732. It goes on forever. But you can see that this is slightly bigger than this side, so this is the short side. So if the short side here is 1, the hypotenuse should be double if it's a 30-60 triangle, and it is. 2 is double the amount of 1. So the short side, if this is a short side, this side would be 60 degrees. If you look back at the chart, notice that the short side here, if this is the short side, this should be 60 degrees, which in our case it is the short side. So I'm going to put that this angle here is 60 degrees. But they also want it in radians, so I guess I better switch that for them. So to figure out 60 in radians, just take your 60, or your degrees, multiply by the conversion. So in this case, this is a degree, so 180 goes in the denominator. And if you multiply here, you can reduce 60 and 180 to 1 and 3, because 60 goes into 60 one time, 60 goes into 180 3 times. So if you multiply straight across, this would end up being 1 pi over, if you put this over 1, so 1 times 3 is 3. So this here is really pi over 3. So I can say this is also pi over 3 as my angle. All right, our next one here is cot equals 1. So this one, again, I'm going to draw myself a triangle. And for cot, it is the opposite of, or the reciprocal of tangent. So tangent, or SOHCAHTOA, TOA for tangent is opposite over adjacent. So cotangent must be adjacent over opposite. So if this is the case, again, this doesn't look like a fraction, so I'm going to force it to be a fraction. So I'm going to put this 1 over 1. So adjacent here is 1, so this side here is 1. The opposite side is also 1, so this here is the opposite one, assuming that my angle is here. I probably should have drawn that. So if my angle is here, this side is adjacent, this side here is opposite. Well, in this case, since both sides are equivalent to each other, this must be a 45 degree triangle. So this is 45 degrees since they're equivalent. And to change 45 as a radians, let's go ahead and do that. So radians, it's going to be 180. So 180 is in the bottom, and in the top here is going to be pi. So the degrees should cancel each other out. So 45 and 180 do reduce. So 45 goes into 45 one time, and 45 goes into 180 4 times. In this case, this would be 1 times pi, which is 1 pi. And then this one here would be 4. And so you really have just pi over 4. And there we go. That is going to be our angle. So hopefully this video was helpful to help you walk you through the special types of triangle. If you have any questions, feel free to come to office hours. Bye, guys.